Hello friends, welcome to the video tutorial on FireBirdV robotics research platform. This platform is based on ATmega2560 microcontroller, which belongs to the AVR architecture based microcontroller family. In this tutorial, we will introduce you to FireBirdV robotics research platform. Earlier about basic building blocks of any robotic system. We will now consider FireBirdV platform and see each building blocks in details as present on this platform. So let us look at the sensors present on FireBirdV platform. First is the sharp IR range sensor. This sensor is used for measuring distance of any object from the robot. It has an infrared emitter which emits infrared light and a CCD array as the receiver. So when an object comes in front of the robot, infrared light emitted from the sensor strikes the object and is reflected back. This reflected ray is received by the array of CCD at receiver side. So a triangle is formed with emitter, object and receiver as three vertices, and depending upon distance of the object, the angle between incident ray and reflected ray changes. This change of angle gives the distance of any object in front of the robot. So the major advantage of this sensor is that it does not depend on color of the object. Even if small light is reflected from the surface, it will be received by the receiver, and hence angle can be found and distance can be calculated. This sensor is available in various range. The commonly used have range of 4 to 30 cm and 10 cm to 80 cm and are called as GP2D120 and GP2D12 respectively. Besides, there are other range sensors also available. The selection depends on application you are using it for. On FireBirdV platform, we can attach 5 such sensors. Positions for placing these sensors are shown in the figure. Next sensor is known as IR proximity sensor. This sensor is also used for distance measurement or can also be used for object detection. However, the range of the sensor is very small. It can measure distance only up to 10 cm. These sensors also have an IR transmitter which emits infrared light and uses phototransistor as receiver. These sensors can be used in conjunction with sharp sensors for better resolution. On FireBirdV platform, we can attach 8 such sensors. Position for placing these sensors are shown in the figure. Next, we have white line sensors. As the name suggests, these sensors can be used for sensing white line. This sensor has red LED as emitter and phototransistor as receiver. Working of this sensor can be explained using a very simple physics. That is, the black surface absorbs all light incident on it, whereas white surface reflects light incident on it. So phototransistor receives different amount of reflected light at black and white surface, and so robot can make out whether it is on black surface or on white surface. Array of 3 white line sensors are provided with the platform. However, array of 5 and 7 white line sensors are also available and can be interfaced easily. Its location on Firebird is shown in the figure. Moving on to the next sensor, we have position encoder. These sensors are used for measuring the distance robot has moved or the angle by which robot has rotated. This sensor has IR LED as emitter and phototransistor as receiver. Beside, there is a slotted disk assembly which is placed between the transmitter and the receiver. The slotted disk is connected to the shaft of the DC motor. Whenever the motor rotates, slotted disk also moves. Now, when the slot is there between the receiver and the transmitter, IR light will be received by the receiver. But when disk comes in between the receiver and the transmitter, IR light will not be received by the receiver. So we get a pulse high and low depending on whether disk or slot is between the receiver and the transmitter. By counting the pulse, we can measure how much the DC motor has rotated and accordingly what is the distance moved. We will cover programming of this in the video tutorial for interrupt, where you can get clearer picture of this. On FireBirdV platform, 2 position encoders are present on both the DC motors. Next we have infrared TSOP receiver. This sensor is used when you wish to control the robot using TV remote control. Remote have IR LEDs and this sensor has a phototransistor. So when you press button on remote, that can be received by the robot using this TSOP receiver. We are using TSOP 1738 on the platform. On Firebird 5 platform, one TSOP sensor is present. Position for this sensor is as shown in the figure. Next we have servo mounted sensor pod. This is an add-on module and not present on Firebird 5 platform. This pod can be used to mount camera or sensors. It has two servo motors attached so we can have pan and tilt motion. This module can be used for things like room mapping or tracing objects and various other applications. Next we have accelerometers. This also is an add-on module and not present on Firebird platform. Accelerometer gives acceleration of object in 3 dimensions. In market, accelerometers are available which can give acceleration either on 1 axis or 2 axis or 3 axis. So depending on it, accelerometer can have up to 3 output pins which can be interfaced with the platform, and accordingly readings can be obtained and computed according to the need. Next we have gyroscope. This also is an add-on module and is not present on the Firebird platform. Gyroscope provide angular velocity of the object. These sensors can be used for maintaining the orientation of the object and hence maintain its stability. Next we have ultrasonic sensors. This also is an add-on module and is not present on Firebird platform. Ultrasonic sensors are used for object detection and distance measurement. One can easily interface this on the robot in the slot provided for this. This sensor can be used as an alternative to SARP sensors. Next we have motion sensors. This also is an add-on module and is not present on the Firebird platform. The passive infrared motion sensors are used for detecting live object. These are found in places such as office or washroom where lights and fans are controlled depending on whether someone is present or not. These sensors can also be easily interfaced on the Firebird platform. Next we have GPS or global positioning system. This also is an add-on module and not present on Firebird platform. This module, when interfaced on robot, can give the location of the robot by receiving signals from the GPS signal. It gives location in terms of latitude and longitude. It's huge and understanding all of it at once is difficult, so I suggest you to use the hardware manual throughout the use of robot. With this we have come to the end of this tutorial. Thank you for listening.